I am Philip Myers, an instructor at National SAR School, and through a series of short videos, we're going to go through how to properly gather information and fill out a Flare check sheet. Using a Flare check sheet will assist us in interviewing the reporting source, determine what type of flare they saw, and help us establish a reasonable search area. Let's say we have a couple walking along the beach, when all of a sudden they observe a flare. For our response to flares, we have three primary policy points we must concern ourselves with. Red or orange flares in color mean distress. It is no different than hearing the words Mayday on the radio. Oftentimes these flares will come in at night, and we will not be able to locate the source of that flare despite our search efforts. So that means we will be going on out again in the morning to search for any unresolved red or orange flare reports. And a flare sighting check sheet must be used. This is the flare sighting check sheet. It is a two-sided form. This is the front and this is the back. But we're going to go through this piece by piece. We need to record information about the reporting source, their name, and at what time did they contact the command center. We need to record how they contacted us. For example, we will say they used a cell phone. Next, we need to determine where they were when the reporting source saw the flare. If they are able to provide a GPS position, that is best. But often, the person making that report is not able to do so. We may need to determine their position from a geographic reference or an address. For our example, our reporting source provided us with a geographic location. The position accuracy is for the operations unit, the OU, or SAR planner at the command center. They are responsible for determining a degree of error to the position provided by the reporting source. The less confident the OU is, the more error should be applied to the position. After consulting a chart, the OU determined only a small amount of error was needed. A quarter nautical mile radius error adequately covers the position given. Next, we need to know if the reporting source is still at the position where they saw the flare. If they are still there, would they be willing to stay in that location long enough for our searchers to arrive and assist us by directing our resources? People may think they have done their duty at this point. They have told the Coast Guard about a flare they saw. We really need more information to determine a good search area. Talk to the reporting source. Let them know that you need to ask them a series of questions to better determine where we need to search. A critical question is, at what time did they see the flare? We cannot assume it was just before we got contacted. There could have been a significant delay from when the flare was spotted until they were able to make the report to us. Meanwhile, the source of the flare is likely drifting. Next, we want to know how many flares did they see. If they saw more than one, can they estimate how much time went by between the flare sightings? Another critical question is, how long did the flare burn? It could have been just a few seconds or a minute or two. We want to know what color it was. Did it appear to be over land or over water? Did it look like it came from the surface or possibly an airplane? Next, we want to know, how did the flare appear to move? Did it just go up? Did it appear in the air and fall? Or did it rise and fall in an arc? Or was it steady, not really moving at all? We want to know if the reporting source had a clear line of sight in the direction of the source of the flare. Or were there any buildings, trees, islands, or sand dunes that obstructed their view? With this information that we have gathered, we are now able to determine the type of flare that was used. There are three types of Coast Guard approved marine distress flares. Meteor flares that typically rise and fall in an arc, parachute flares that tend to appear in the sky and fall slowly because of a parachute, and handheld flares that appear to be steady with no rise or fall. Although they could be intermittent, where we can see the flare, then loom of light, and then the flare again as someone rises and falls in heavy seas. With what we have learned, we can go to the Coast Guard Addendum, Appendix India, Table India 2. We compare the characteristics of how the flare moved and how long it was observed with the type of flare. In our example, we can determine the reporting source, observed, a meteor flare. Let's note the flare type on the check sheet. We also want to know if the reporting source can see any boats or aircraft in the area of the flare. It could be the source of the flare or other possible leads the command center can contact. We need to know something that is referred to as the reporting source's height of eye. It is not just how tall they are, though that is part of the information needed. Most people fall between 5 to 6.5 foot tall. That difference is negligible. What we truly need to know is how high are their eyes above the water. To that, we may need to know if they are on a pier, in a building, or on a cliff overlooking the water. If they are on a pier or some other structure, have them estimate how high they are above the water. If they are in a building, we need to know what floor they are on. To estimate their elevation, we use 10 feet per floor. And if they're on a hill or a cliff, we can use topographical maps to determine their elevation. In our example, our reporting source was walking along the water's edge. He is 5 foot 6 inches tall, so we're going to round it up to the next whole foot. Thank you for watching. The next in the series will be to determine the bearing direction the flare was observed.